Hey, hello. Welcome to my stream. Um, Hopefully you meant to be here. If not, well, sorry about that. um, my name is Andy Turley. It is Friday, January 25th, and I am going to keep working on my Pony Twitch IRC bot. So I've been working on this for a few weeks, I guess, just kind of in little increments here. Um, if you are interested in seeing where it is so far, you can go to GitHub. If you go to github.com/aturley/ which one is this? Twitch IRC bot. I'm trying to keep things updated, so I'm not necessarily very good at it, but I put everything from the last stream in recently. So this is a library that you can use to build your own IRC bot in Pony. So it started out as kind of a standalone app, and I separated out the application, my specific application, and the library here. So last week we made some changes to the library so that we could actually modify the object that handles the IRC calls, which means that you can have state and update that state. So that's kind of useful. So today I want to talk a little bit about what do I want to talk about? I think I want to modify this a little bit more and talk about how we would change this so that we can respond to other kinds of events besides TCP events. And in the process, I'll show you a little bit about timers and actors, and maybe get into a few other things. So let's start. I guess just to bring everything back up to speed, we've built this bot, and so I can run it. Should connect to my Twitch channel, and it'll say Wilbur. Hopefully you can see this. I've added a little plugin thing for OBS so that you can actually see the chat in the video now. That'll be useful, I guess, when I start putting these things up on YouTube. But anyway, this is the bot so far. It doesn't do anything super interesting. Last time we added a thing where we count the number of times different users have said hello to it. So you can say, "Hello, famous Mr. Ed." Famous Mr. Ed will respond. And then we can do name count, and it will tell us how many times different users have said hello to it. So nothing really earth-shattering, but it's kind of a fun little parlor trick. So let's add a little bit more fun stuff to our famous Mr. Ed chatbot. Okay, so again, I've got this library code up here. This is generic Twitch IRC code, and then I've got my application code down here, and this is the stuff that is specific to my chatbot. So it's not a terribly long program. It probably could be shortened a little bit, but let's not concern ourselves too much with that for right now. So the thing that I would like to do now is have famous Mr. Ed send a message to the channel if there hasn't been any conversation in a little while. I want him to get people pumped up about being here. So what we're going to do is we're going to figure out a way to send a message, something along the lines of, hey, quiet in here, or something like that. If there haven't been any messages in, let's just say if there haven't been any messages in 1 minute. So it'll be kind of an impatient chat bot. This will probably get really annoying. I don't know if I'll keep this feature, but let's look at how we do it. So in Pony, basically the Pony runtime can send lots of different kinds of events to a program. And so right now, we, in our IRC bot, in the library, we end up getting messages when when a message comes in via TCP. And those are our IRC commands. So what's happening in the runtime is that there's actually what's called an actor that's set up that responds to these messages. So the Pony runtime, when it gets an incoming TCP message, it sends that data to the actor that's responsible for that TCP connection. And so that's what happens is when that actor is called, it then does a little bit of magic, basically. And then it calls our TCP connection notify class that we've created. So we've got this specialized Twitch chat connection notify. And so there's the actor that's handling the TCP connection, and it's basically processing these incoming TCP messages asynchronously. When it calls into this object, this Twitch chat connection notify object, that is handled synchronously. And so it's effectively a function call from the actor into this received method here. So another kind of event that you can get is you can get a timer event. So you can basically set up timers within Pony, and you can say, hey, send me some sort of notification when this thing happens. And when the timer fires, a function will be called. So what we've got here is this interesting situation where we have an actor that's handling timer events and some sort of actor that's handling network events. And because of the way Pony works, we can't really share an object to handle both of those things. So inside our TCP receiver, we're calling this our IRC message responder class or object. And we would like to be able to handle our timer events in kind of the same place, but we don't really have a way to do that because this thing is an object, and this object basically can only be called into by the TCP connection handler actor. So what we're going to do is we're going to change things around a little bit, and we're going to make our IRC message responder class into an IRC message responder actor. And that's going to give us now this asynchronous thing that can be called by either the TCP, that can receive messages either from the TCP handler actor or from a timer that fires something. So let's take a look at how we want to start doing this. So the first thing we'll do, let's just just, let's turn the IRC message responder into an actor. So we've got this interface that defines the methods that are available on the IRC message responder. And they're all functions, and none of them return anything. So this is actually good. So what we're going to do is we're going to turn these into behaviors. And a behavior is a method that handles an asynchronous message on an actor. So only actors can have behaviors. Classes can't have behaviors. So you could see classes as kind of being degenerate actors, or you could see actors as being even more powerful classes. Either way, in order to have behaviors, the thing that has behaviors has to be an actor. And because actors are asynchronous, when the behavior is called, it just returns immediately, and it doesn't have a return value. All the processing is then done by the actor asynchronously, and the actor that called it, or the actor's context it was called within, just continues on its merry way. So that's why I said it was nice that none of these things actually return any values, because we don't have to try to come up with some mechanism to pass values back. These things all work with the arguments that are passed to them and don't require the caller to do anything. Okay, so we've changed these things from functions to behaviors in the interface. And so we are going to go and turn this my IRC message responder from a class into an actor. And then we're going to change these handler methods into behaviors as well. Okay, and so we should be able to build this, and functionally, it shouldn't do anything differently. It should still behave the way that it behaved before. So we should be able to say hello to Mr. Ed, and Mr. Ed will say hello to us when he connects. Mr. Ed should say Wilbur. Okay, we got a message, an error here. So line 40, this parameter must be sendable. ISO, val, or tag. Okay, so ISO, val, and tag are reference capabilities in Pony, and what this error is telling us is that we are passing an argument off to an actor, and the argument has the wrong reference capability. So this could probably be a slightly better error message, because it doesn't actually tell us what the reference capability of this thing currently is. But if you know enough about Pony, you'll know that by default, objects have a reference capability of ref. And so this thing has a reference capability of ref. So if you're not familiar with reference capabilities, what this means is that params is a reference to a thing that can have other readable and writable references to it. So params is a readable and writable reference to something that can also have other readable and writable references to it. Now, if you've ever done any multi-threaded concurrent programming, you might see where this could be a problem. Basically, if we have, so just as a little background, actors are the unit of concurrency in Pony. So if you want to do anything concurrently, you have to have actors. And by default, you actually already have some actors that you don't even really think about too much when you create your program. For example, your main function is run in the context of the main actor. In input and output are handled via actors. I was just talking about the actors that handle timers and TCP connections and things like that. So we've got this behavior that we're sending something to, and we're saying that it may have other readable and writable references elsewhere in the program. And the problem with that is that if you have this thing that can be read from and written to from other places in the program, then that means that those things could live in other actors. And what that means is that you could have another actor, for example, writing to this to params, or the thing that params points to, while this actor is trying to read from it. Or you could have two actors trying to write to it at the same time. So this is a race condition, and Pony, one of Pony's selling points is that the compiler prevents data races. And so the way that it does that is it keeps track of the reference capabilities of the different references to an object, and it makes sure that they're always consistent with not having data races. So, as I said, right now params has a reference capability of ref, which we don't actually get told about anywhere in this error message. And the message is saying this parameter must be sendable, ISO, val, or tag. So ISO, val, and tag are considered sendable because they make certain guarantees about the variable, the reference, that ensure that we aren't going to have a data race. So ISO over here means isolated, and it means that the object that this thing refers to has only one readable and writable reference, and it's the reference that you're looking at right now. So if you have an ISO reference, then that's the only thing that can refer to that object unless you give it up. And there's a few different ways that you can give up a reference. So that's safe because you know that no other actor can access the thing that this reference points to. Val means that you have a read-only object, that there may be other references to it, but they're also read-only. And so the only thing you can do with the thing is read it. And that's safe across multiple actors because you never have any actor writing to the data, and so you know that you'll never have a data race because reads are always safe. And the last possibility that we could use here is tag. And what tag means is that you have a reference that can neither be read to nor written to. And you might say, well, what's the point of a tag? Well, what you can do is if you have a tag reference to an actor, you can still send it messages. So asynchronous messages. So you could have a tag reference to something and you could be sending it messages even though you can't read or write to it. And so these three reference capabilities are the sendable reference capabilities. And what we need to do is we need to make params one of those things. So just reasoning through, let's take a look at what we're doing with params. Let's see here. So yeah, so params is an array of strings. And it's the parameters that are coming from, it's the IRC command parameters that are coming from the IRC command that was sent. And so we need to be able to read them because we probably want to be able to do something with them. For example, here, well, yeah, here we need to be able to read out one of the parameters to figure out what the channel name is. So we can't make this tag. So our two options are val or ISO. And ISO is nice if you have something that you want to pass into a behavior, pass as part of a message to a behavior, and you want to be able to modify it later on. So it gives you this thing that you can take and modify later on if you need to. In our case, we don't really need to modify this thing, so we might as well make it a val. So we're going to change the definition in the interface and make this a val. We already changed it down here where we're using it in the program. And now what we need to do is we need to modify the params array itself so that it's a val. So let's take a look at where we're setting it up. So right now we create this params object and we say that it's string, and then we start putting things into it. We start chopping up our IRC command and pushing strings into it. So we want this thing to eventually, we want to eventually have a val that we can do something with. So what we're going to do is we're going to get an ISO array. So right now this array is ref. So what we want is an ISO, and we're going to take that ISO, we're going to modify it a few times by pushing things into it. And then since we know we only have one reference to it, we can do what's called a consume, where we consume the variable, and that gets rid of the existing variable. And so now we have this object that we know has no other references to it, and we can then assign that to some other variable that has any reference capability, because we know that there are no other objects that have, no other variables that reference this thing. So we're guaranteed that basically we can make any other, we can use any other reference capability on it, because there's basically no constraints. There are no laws. So recover basically says, give me this thing inside a recover block. Some people have said some people have described it as a magical place. Basically what this means is that you can have something that's a ref, and when it gets returned from the recover block, you can give it any reference capability you want. So in our case, we turn this ref into an ISO. Now, one of the tricks about a recover block is that you can't use any ref variables within the ISO block, or within the recover block. Right now we're not, but it's just something to be aware of. There are some rules about what happens inside a recover block. We are not violating any of those rules, so we shouldn't have anything to worry about right now. So we create this ISO, and then down here when we use it, we need to consume it. And actually, I think what I want to do is just create another variable. So I'm going to have this params tick variable that I'm going to use instead of params. And this is going to be the one that has a val reference capability. And that's going to make it a little easier for me to access individual elements from the array. Okay, so I think I've gotten this right. It didn't like that. Let's see, what did I do wrong here? Okay, so this is a different set of errors. So this is one thing about the Pony compiler, is that sometimes one error will block the other errors, and so you won't see the other errors until you fix one of them. Different compilers have different levels of ability to kind of figure some things out. So what's happened here is now we have an error where we're creating our IRC message responder and passing that off. So let's take a look at that. That's on line 97 of main. And the problem here is that, let's see, parameter type is ISO, argument type is tag. So we need to change that. So we need to change our IRC message, Twitch chat connection notify to take a IRC message responder ISO. Or tag, sorry, tag. And I don't actually have to say that it's tag because it's an actor, and by default actors are, references to actors are tag. And then we can get rid of this consume here because we're no longer consuming an ISO. And we can get rid of the recover block here because when this gets created, it creates an actor, and again, the reference capability is tag. So that should get rid of that error. Okay, receiver type is not a subtype of target. Okay, I'm using, so the receiver type is ISO and the target type is box. So what this is telling me is that I've got my params variable and it's ISO, but in order to call the values method on it, it has to be box, which means that it needs to be a ref or a val or a transitional. And so what we're going to do here, let's go back and look at that. So I'm calling params.values here. Really, let's just move the params tick variable up above here and use that here. So now I'll have a params val, and we should be able to call values on it. And those are the only two errors, so hopefully we've got them all now. Okay, so line 34 in botlib. This parameter must be sendable. So again, we've got something that's an ISO, that needs to be either an ISO, a val, or a tag. Oh, okay. So because this is an interface, Pony doesn't know that it's going to be used for an actor, even though it has behaviors. So maybe you could argue that it should be able to figure that out. Let's just explicitly say that this is going to be an IRC message responder tag. And we'll probably need to say that here too. Okay, so that builds. So let's run it again. And there's famous Mr. Ed saying Wilbur in the chat channel. So that's kind of cool. All right. Okay, so that was step one. So remember, our goal here is that we want to be able to also respond to timer events. So we've got this. So the next thing we're going to do is we're going to set up that timer. And so this is going to be something that we want in our application. This isn't like a general thing that people would want. So let's take a look at the documentation for timers. That's in the time package, timer.pony. And this is one of the well-documented classes that actually has a here doc at the beginning that tells you how to use it. And from time to time I forget how to use these things, so this is a nice thing to have. So it's got this nice example program here that just creates a timer that goes off. So let's just kind of walk through what this does. We get this reference to timers, and then we create a timer object, and then we pass it off to the timers. The arguments to the timer object are this notify class, or notify object, and then two numbers. The first number tells the timer how long to wait before the first time it fires, and the second number tells it what interval it should fire at after that. And these are both in nanoseconds, which is why they're so enormous. Pony lets you do this thing with the underscores to break up a big number so that you don't have to sit there and painstakingly count zeros. You can visually look at it and count groups of zeros, which is a little easier until you get to much bigger numbers. So anyway, this notify method or notify object then is of type timer notify, and the important part is that it has a method called apply, which takes a timer and the number of times that timer has been called since the last time, or the number of times this notification has been called since the last time it was called. Sorry, the number of times the timer has gone off since the last time the notifier was called. So the way that Pony is written, it's not a hard real-time system. It's more of a, it's not real. It's a soft system. And so basically, if the system becomes overloaded, you could have a situation where the timer notified doesn't get to run until after several times of the timer going off. And so that's why you get this count here. We're probably not going to have the system so loaded that happens, but that's the thinking and the reasoning behind setting it up this way. So what we want to end up doing is we want to create a timer, and then we want a notification object, this notify object, and when the notify object's apply method is called, it should call the IRC handler and basically kick it and say, hey, send a message of some kind to it that says, hey, this timer has gone off. So let's do this. Gonna add a few things here, and I may decide that I'm wrong in what I'm doing. And let's just first set something up that notifies us let's just have it, we're gonna have it spam for a few seconds into the channel. Just do every 5 seconds, so. So I want to hang on to a reference timer because I want to be able to stop it. If later on, I'm going to want to be able to stop it and maybe create a new timer even. But for now, let's not worry too much about that. But let's see here. I want to create a timer notify. And we'll just call it, we want this thing to whip up, and let's call it spam. Timer notify. This timer notify. And we want this function to take a timer and a count. And the type of the count is U64. Oh, also it returns a Boolean. If you return true, that means that the timer should keep going. If it returns false, then that means the timer should stop. So let's just say we're going to return true for now. And for now, let's just debug, send a spam message to the console so that we can see that this thing is working. We're going to stick our spam timer notify in here. Okay. And let's rebuild. Can't find definition of timer notify. Oh, okay. Yeah, I need to tell it to use the time package. Can't find declaration of spam timer notify. Because I misspelled notify. Notify. Can't find declaration of timer. So I need to I used a variable without defining it. Cannot assign to a let or embed definition more than once. Where am I doing that? Line 23. Oh, for some reason I said timers equal. I meant to do this, I believe. Yeah, we call the apply method on timers and consume the timer. Okay. So now we should be able to run and we should see a spam message appear in the console every 5 seconds. There we go. Spam. Spam, spam. Spam. Okay, so that means that our timer is working now. So that's great. We can spam the console, but what we really want to do is write out to the TCP connection. So what we're going to do is we are going to have the TCP connection be a parameter of this timer. And then we're going to set it when we create this thing. Okay, so let's go look at how we're gonna get that connection in there. So this is where things may start to get a little bit interesting. What we want to do is we want to set the connection, and there's a few different ways that we could do that. Some of them are more complicated than others. So every time we call either the priv message or command or one of the other things that gets handled by the handler, we pass it the TCP connection. We probably want to have some way of passing that in as soon as the connection is established, and then maybe we want to just hang on to that rather than passing it in. So there's a few different things that we could do. One is that we could add a behavior to our IRC responder called, let's just call it connected, and we'll pass the TCP connection there. So let's do that for now. Then we'll add our implementation in our application, in our handler. Okay, now an interesting thing about this, one thing about Pony is that all of an object's properties have to be set to something in the constructor. And so we're going to want to have a underscore con variable here. And we're going to make it var so that we can modify it. And if when we start out, we don't have a TCP connection. So actually what we need is for this thing to be none or TCP connection. And that way, down here, we can say con equals none. And then later on, when we get that connected message, we can set con. But what this means is that when we want to use this underscore con, we need to check it to make sure that we can use it. To make sure that it's a TCP connection and not none. And also, since we want spam timer notify to have access to the TCP connection, then we actually need to defer setting the timer up until we've gotten the connection. So we need to move some of this logic out. Since we're not really doing anything with this underscore timer here, let's get rid of it for now. And let's do this. Okay, so now we set up our timer only when we've got the connection. And we pass it. Let's just pass the con, because we know that TCP can, we know that con, not underscore con, but con is a TCP connection. So we know that that's valid. So we should be able to do this. We can clean things up later, but for now this should work. Okay, and then the other thing that we need to do is we need to actually call that connected method inside our TCP notifier. When we get connected, we need to call IRC message responder con. Okay, and what else do we need to do here? Since we want our let's see. So we want our spammer to spam to a particular channel. Let's hard code the channel for now, and then we'll figure out later how we want to pass that channel in. So basically we want to write the message spam out into the channel. And like I said, we're going to just hard code the channel for now. Okay, let's build this and see what happens. Can't find declaration of con. Did you mean underscore con? So that's in, it's on line 15. Oh, okay. Yeah, we want underscore con because that's our connection. And can't find RC message, so I must have screwed something up and used the wrong variable name. That's on line 46. Oh, 46 here. It's right here. Time. Okay, spam timer notify. Argument is not a subtype of parameter. Right, okay. So argument type is spam timer notify ref. Parameter type is timer notify ISO. So Pony does, if you don't have a create method for a class, then when you create the class, you get an ISO object back. But if you do have a create, then by default you get a ref unless you tell it explicitly that you want an ISO. So let's do this, and this will cause the constructor to give us back an ISO rather than a ref. And that was the problem here, is we were passing a ref where we needed to pass an ISO. Line 46, couldn't find apply. I think that was where I meant to call connected. Yeah, I meant to call the connected method on the IRC message responder. Oops. Yeah, as I'm sure you've noticed, a lot of this stream is just watching me fix stupid errors. But I like to think that it's useful. If anybody ever tries to use Pony, they'll have seen some of these errors and have some idea of where to start. Okay, so let's connect. What I expect will happen is that we'll get our typical Wilbur message from Famous Mr. Ed, and then every few seconds he'll send out a spam message to the channel. There we go. Spam. Spam. So 3, 2, 1, spam. Yeah, okay. So Famous Mr. Ed is working as expected, which is to say that he's being annoying, but that's okay. All right. So our goal was to have Famous Mr. Ed send a message only when there hadn't been any activity in a certain amount of time. So let's see if we can hack that together real quick. So there's a few different ways that we could do it. One would be to just have the timer fire periodically and see if there's been any activity since the last time it fired. If not, it'll send a message. If there has, it won't send a message. That may be the easiest thing. A slightly better thing would be to, every time we receive a message, kill the old timer, create a new timer, and basically have it start the timer over again. It's a little more involved. So let's do the cheap and easy thing first. If you know anything about me, you know that that's my typical MO. So just call this has been chat, make it a Boolean. We're going to set it to false going in. And then oh yeah, I guess what we wanted to do was silly of me. Really what we wanted to do was tell our IRC message responder to send a message out. So instead of doing this from within the timer, we really want to call a method on the IRC message responder and have it do this. Let's do that first. Okay, so let's look at this. Let's create a behavior called spam, and it will not take any arguments, and it will be responsible for sending this message. And so this is where we're actually going to have to use the con that may be either none or a TCP connection. So we're going to use a match statement here. We're going to say that if it's a TCP connection, then we assign it to this variable called con, and we send the spam message to the channel. That means that our spam timer notify, instead of taking a connection, instead of having something that stores the connection, we actually want to store a reference to my IRC message responder. We'll pass that in there. And use our little abbreviation here to set that. And then we'll call spam behavior. Okay, this is better. So now this makes it so that our actor is actually the one doing the work. So now we need to modify this thing, and it takes an argument of this, which is the reference to the my IRC message handler object. Let's see, because we no longer need to wait for the connection here, we can move this back into our constructor. Or I guess we could leave it there, doesn't matter. All right, let's build this. IRC message responder, unexpected. Okay, line 11. Oh, okay. So the real problem here is that I was trying to create this constructor and I left off the arrow greater than for some reason. So I didn't know that that was a method. Okay, let's connect. And there we go, we see spam. Okay. So back to where we wanted to be. Okay, now has been chat. Let's get back to that. This is the thing that tells us if there's been a chat message or not in the last however much time. So we're just going to say that if there has been any sort of private message, we're going to set this to true. So let's just do it at the very beginning. And then down here in spam, we're going to say if not has been message, then do this, and then just always set it back to false so that we start waiting again from this point to see if there are any more messages. Okay, let's build that. It wasn't has been message, what was it? It was called something else. Has been chat. Sometimes I forget my variable names. Okay, and let's fire it up again. So we see spam. Now I should be able to just keep talking, and that should. So we haven't seen any spams yet. But as soon as I stop talking, I should start seeing spams again. Yep, there we go. Spam. 5, 4, 3, yep. 3, 2, 1. Yeah, okay. So it's detecting that there hasn't been any activity and it's spamming the channel. So to kind of wrap this up, instead of saying spam, we can say something really silly like, let's make some noise in here. And instead of doing it every 5 seconds, we can do it every every 5 minutes. And every 5 minutes, if there's not been any activity, it should say, let's make some noise in here. So, I think I'll call it a day there, but you've seen a little bit more about reference capabilities. You've seen some stuff with actors and behaviors and timers. So hopefully that was interesting. Tune in next time. Take care.